So let me summarize the notation a little bit. So the fundamental evaluation problem is that you cannot observe the same person in two different states at the same time. So on an individual level, the causal effect is not measurable. So because either you observe the outcome of an individual in state 1, or you observe the outcome of an individual in state 0. So this would be then the outcome in case of participation, and why not would be then the case of non-participation. So that's the first thing we should have in. So if you look at a randomized controlled trial, RCT, so we have a target group that has potential access to a program, and what we do by randomizing and flipping a coin, then we assign people to the treatment group or to the control group. In other words, for the control group members, access to the treatment is randomly denied. That's what randomization does. And that's how we get a potential outcome of the counterfactual behavior of the treatment group. Having done that, we could measure the causal effect by taking just the difference in means, so the mean outcome here of the program group minus the mean outcome of the control group. So we do not need any econometrics if the randomized controlled trial is conducted properly. We could just take the difference in means and thereby getting the causal effect. So using econometrics to measure the causal effect, we take a regression model, so with the outcome which depends on the intercept, and take an estimated treatment dummy, and the regression line is then the outcome hat equals beta 0 hat, and that beta 0 hat, the intercept, would then be the mean outcome of the control group. So this is the mean outcome of the control group, and the beta 1 hat is then the causal effect of the program. That's what we do then using R. Just once again, the beta 0 hat is the mean outcome of the control group, and the mean outcome of the program group is the beta 0 hat plus the beta 1 hat, and the causal effect is beta 1 hat. So how do we identify the causal effect using expected value notation? So what we want to do is we want to get rid of the so-called selection bias, right? So this is here then the selection bias. So if there is a difference between the unobservable counterfactual behavior of the program group and the observable control group behavior, so if there is a difference between these two mean outcomes, then we would have a selection bias issue. And how do we get rid of the selection bias? And that's what we call the identifying assumption. We get rid of the selection bias by a plausible assumption. And the plausible assumption is that the unobservable counterfactual is identical with the control group behavior. And why should that be plausible? In case of an RCT, we randomly deny access to the control group so that this assumption should hold. Once again, the selection bias is the difference between the unobservable counterfactual and the observable control group behavior. And if the difference is non-zero, then we are in a world with selection bias. If the selection bias is positive, then there's a positive selection into the treatment group, and if there's a negative selection, we have a negative selection into the treatment group. And in order to estimate the causal effect, we have to get rid of the selection bias, or in other words, we have to get rid of positive selection or negative selection. So what is the average treatment effect on the treated ATT? So that's the difference between the observable mean outcome of the program group and the unobservable counterfactual behavior of the program group. So this one here is not observable, and if we allow for the plausible assumption, then we can take the observable behavior of the control group as a proxy for the unobservable counterfactual behavior of the program group. And this allows us to estimate, right? That's the estimate, the ATT hat. This allows us to estimate the mean, the causal effect. So this one here is observable, this one here is observable, and then we can measure the causal effect, ATT hat. Precondition, of course, there are no other biases like substitution bias. Well, and now it's time to do an R session using the R code that is available on GitHub and doing a randomized controlled trial interpretation here using R.